to another coding ASMR video. Today I will do some more coding recursion challenges where I solve problems with recursion. So let's begin. In the last video I've done some recursive problems on strings, mainly finding x or something, inserting x or asterisks. But now I'm going to do some problems where I have to use substrings. So let's get on to it, shall we? Given a string, compute with recursion. Calculate recursively without loops the number of 11 substrings in a string. The 11 substrings should not overlap, so let's say if I call the count11 function method that takes in these strings, it should return 2 because it has two 11s, one here and one here. If I call this method abc 11x11x11, I should return 3 because there are 3 substrings of 111111. If I do this, if I pass in 111, it should still return 1 because they should not overlap. So let's try that. I'm going to create my method now. Public static. So I think it should return int which will be count11, and I'm going to take in a parameter, meaning the string I will take. So string, let's call it word for now. And first I'm going to determine my base case. So what I'm thinking of doing is each recursive call, I'll call the function itself but on a substring, so like that. And I'm going to recursively call until the string has a length of 2. So if the word dot length is, let's test if it's greater than 2, because once it's 2, if it's 2 or more, I'll recursively call, but if it's 1 or less, I should stop recursing. So greater than 1. And then let's test the opposite. Let's do if word dot length is less than or equal to 1, I'm going to return 0. That is my base case. Otherwise, I'll recursively call something. So let me think for a bit. From this point, I'm gonna only type until I found something that I'm on track. So I'm gonna just type until I make some progression. So Okay, so I've made some code here. So for my base case, if the word is less than 1 or less, like one character, I'm going to return 0. It's my base case. Or else I'll continue the recursion. So to make sure to test it, the word has an 11 in it, I'm going to test that the first two characters of the string are 1 and 1. Oops, it should be 1 here. If they're both 1s, the first and second character in the string, I am going to take a substring that is removing those 1s and adding 1 to it, so return 1, and I'll recursively call it again, but on a substring with those 1s removed. And then it's going to recursively call that. So, and if it doesn't find, if the first and the second character aren't 1s, I'll return 0, which means that there's no 11 substring. The first and second aren't 1s. And I'll recursively call by chopping off that first character only, because it's not 1 1. And recursively call. So let's test it, shall we? So these are the results. So as you can see, if I call this method, it returns 2. So that's expected. If I call this method with that string, it returns 3, which is expected. And if I do this, count 1 1, with 3 1s, it returns 1. So basically, that just does it. So I am going to try and trace some of the code to explain the recursion. So this is why I made the print statements here. So let's see. I'm just testing the same code, but I know it works, but I just want to show how to trace it by printing these substrings. So this is the first call, substring. This is the first call. The full string is ABC11x11x11. So in the first pass, it didn't find a 1 1, so take off 1 character at the beginning. The next recursive call, it didn't find a 1 1 in the beginning, so take off that character, return a substring, and recursively call with a substring that. The next string, it finds a 1 1, calls it, adds 1, recursively calls with a substring of 1 of that, which removes 1 1, and then doesn't find 1, finds another 1 here, the next call, and adds 2, adds 1, so 2 in total. Substring that, remove the 1 1, call it again, nothing, and then I run my last recursive call, 1 1, and that finds a string here that's 1 1, and I add 1, so it gives me 3. So that's why it printed 3 here. So that's how I just traced the code here. So I'm going to remove these and declare it finished. So this was pretty easy, so count 1 1. Let's head to the next problem. Let's do this, shall we? Alright. This one's a bit harder. And here it go. Given a string that contains a single pair of parentheses, compute recursively a new string made only of the parentheses and their contents. So made only of the parentheses and their contents. So XYZ parentheses ABC yields only that. So basically I'll have to substring, take out a string that here, and and try to just extract any characters outside of these strings. And in fact, I have to use recursion here as well, so that's not going to be easy. So, well, for the state of this video, it's harder to kind of talk while coding. So, to be honest here, I might as well just type only, and once I make progress here, I'll kind of explain something. So let's begin. Let's start this one. Missing return statements. Not good. Not good at all. Not good at all. Oh, I'm just gonna do some recursive. I have to first chop the string and add it recursively. Okay, so I am just testing the code here for one pass. So if it finds a opening parentheses, I'm going to take a substring starting from the parentheses and ending at 1. I'm ending at the last parentheses, so I'm going to include it because it takes a substring. The ending is exclusive, so that's why I didn't include the parentheses. And here I'm going to do it the same thing, or I'm going to test it. And as you can see, this is the string I want and the string I'm going to recursively call. So I am going to return here, return that first substring, and concatenate with a recursive call. Even though it assumes that there's only one pair of parentheses. Recursively call the other substrings, so let's do that. And I'm going to explain you the base case. If the string is less than 1, return an empty string. So now I'm going to try to call it. I'm going to test one function and let's see what I'll get. And there you go. Here's 1. I pass in this one and it gave me this parentheses only. So I'm going to try and see what I would get on the other ones. Okay, so after I've done my cursive problem, I tested it and it happens that I get the same results, the same expected output. So like I said, if I call this function parent bit, which is taking that string, it only gave me this one, which is expected. If I do this with hello, it only prints hello. If I do this, if I pass in that, it only printed XY. So in here, this assumes that there's only a single pair of parentheses. So I continued the recursion that scans for other pairs of parentheses. But in this case, I could stop the recursion immediately once I found the closing parentheses, because this problem is only asking for one pair. But if I do another pair of parentheses at the end, let's say like this, 1, 2, 3, 4, 5, Sova, hello, blah 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 blah. If I do that and test it here, it should give me the other pair of parentheses. And hopefully it doesn't toss an error. Yeah, ABC 1, 2, 3, 4, 5 Sova. So I guess I should call this a success, and I've done my recursion completely. So there's this one problem that I am kind of unsure, but since time is running out, I'm going to end this video here. So I hope you did enjoy this video. Stay tuned for the next video, which will be probably the Backrooms follow-up video. Peace out.